Thanks everyone.
Thanks everyone for coming. Brisbane Serverless Meetup, the first in this year. I think quite a few of you attended this meetup before, so you know that it's always exciting. We're going to have two speakers tonight. We're going to have Bojan. Bojan came back from reInvent, so he went to Vegas, had some good time there. Supposedly attended some AWS events, but not sure about that.
I can neither confirm nor deny that.
Yeah. So Bojan is going to present a serverless lens on the recent updates from reInvent and probably his ideas on what's coming next this year. And then we have Michael Kingston, who's going to talk about some interesting use cases around how to use serverless for video-assisted refereeing in powerlifting competitions. So it's quite exciting to understand how you can use, I think, AWS Cloud Native offerings. So this event, we're at Mantel Group office, so it is sponsored by Mantel Group. That's the logos you see on our t-shirts. If you're ever interested in consulting, if you're ever interested in actually getting some consulting experience, reach out to myself. I'll probably can connect you to our HR and recruiters. And also just a heads up, we do have a few other events happening in Brisbane coming. So we have a user group, AWS user group on Thursday. And we're also going to have Data Inch Bytes coming in March. And probably more importantly, and I think Bojan is going to talk about this, we've been confirmed to host AWS Community Day.
Woo! So to give you a quick, thank you very much. The short and long of it is, if you could imagine a summit dedicated for the Brisbane community, that's what you'll be getting. So quite a lot of us across Australia, the Sydney Serverless, Brisbane Serverless, the Wollongong user group, the Brisbane AWS user group, the Melbourne AWS user group, and a bunch of others that come together to bring a very special event. It is in August, TBA exactly when in August. Quite a few of us here are actually in attendance, part of the committee. You've got Rowan, you've got Alan, Ilya as well supporting, and the wonderful speaker himself, Michael Keaton's on there too as well. And we can't wait to tell you more, but we have to wait to tell you more. So keep your eyes out on LinkedIn from posts from any of us, because there's going to be a whole lot that's going to be coming. So yeah.
All right, so over to Bojan for the first part.
Okay, wow. All right. Let's see if I can just quickly pop that on and we'll go from there.
And I think once Bojan finishes, we'll have a break and we'll have pizza, so don't worry. I'll look after pizza.
Alrighty. Very ad hoc here. Where's presentation mode? How many? Cool. Hello, everyone. So yes, that's right. I went to reInvent. I actually spoke at reInvent. So I had the chance to present on the topic that everybody loves, AI, but in the real world lens. Whoa, don't you go back. Come on. Didn't need that. We'll get back to that in a sec anyway. Long story short, I presented at reInvent. It was a fantastic time. I spoke on infrastructure as code and AI, basically through the tale of 3 individuals who basically suffered and found fixes. Long story short, if you're using AI with your infrastructure as code, guardrails, guardrails, guardrails. If you don't know what a guardrail is, security, security, security. More so than before. So look, let's kick it off. I am going to kind of power through these. If you have any questions regarding them, guess what? You can ask them later, and we'll talk about them later. First off, we have a visual update for AWS Management Console. It's not as bad. Quite literally the best way to put it. It's much more fluid. It finally comes with native dark mode, no more third-party extensions, which is great. Going on with that, quite a few storage announcements came through as well. The relevant ones for us, you can now directly using Amplify hosting, set up your static hosting. Reason why they did that, they saw a lot of success with the serverless stack SSD if you've used it before, and serverless framework who had their own forms of doing it. AWS said, you know what, we can also do it using our own Amplify framework. So if you need static sites and you want to do it AWS's way, Amplify is the way to go. Data integrity protections for S3, for the security people. They've just got new checksum algorithms. They're using the CRC64 NVMe. Long story short, it's just the easiest and newest to use, and it's the default for the SDK. Storage browser for S3. Who's had to go through a S3 bucket looking for something before? And how painful has it been? Keep your hand up, because it definitely has. Well, storage browser kind of gives more of a, you can think like a directory sort of view to that, which makes everybody's life a lot easier. And as always, when it's good for S3, it's good for the transfer family. They've added web apps, which kind of gives you a customer-facing version of what we had before. S3 tables. This one's huge. This one's absolutely massive. I'm going to spend a little bit more than 1 second on this one. If you're anybody that uses Parquet files or any sort of data lakes or anything at all that requires you to query S3 with a lower latency, as well as the ability to integrate it with things like Apache Iceberg, we're talking about your Databricks, etc. They've made it native, and it is, I believe, as of today, GA in 3 regions, and I think in Sydney now as well. I say I think with an exclamation mark, do your Googling. It's fantastic. So if you do use Parquet and S3 right now, check it out. And to follow that, we had the metadata side. Previously, what did you have to do for your S3 metadata? DynamoDB, right? Which is using another service, which means app logic got more difficult, which means you had to use another SDK or more functions outside of the norm. Now you can just use it natively. Going on with that, there's a bunch of other announcements. If you want to take a picture of what they are, take it now. A bunch of them came out before reInvent, and then a couple came out during. And FYI, for those that don't know, the weeks and months leading up to reInvent, there is pre-invent. This is where a lot of the services come out, a lot of the interesting stuff comes out, which I'll touch on shortly.
Go ahead to interrupt. It says pre-reinvent, so like that should be pre-invent.
Hey, blame AWS, not me.
AWS? All right.
Yeah, blame AWS. All right. Thank you, Rowan. Compute and containers. Predictive scaling for ECS. Anyone use ECS? Yep, there you go. Now you can basically say, hey, I forecast in, or you let the algorithm do it. Through ML, they can basically say, scale it for me whenever I need it to. So they can scale up and down when you have, for example, an increase in traffic. Let's just say you do transactions processing. It'll do it for you. Caveat, it costs money. Future data capacity reservations, it basically says is I know in the next 120 days I'm going to need more EC2 than most. I can update my service quotas. New instances, short and sweet of it is more Graviton, more graphic cards, thank you NVIDIA, and low latency NVMe. What does that mean for serverless people? When I build my stack to pretend like there's no servers behind it, it's much more powerful. EKS auto mode. No one likes looking after, what do you call it, Kubernetes? Even, where is he? Hold on, Dimitri, where are you? Well, there we go. He definitely loves it. But anyway, this makes it easier. They beat Google to the, well, no, Google beat him to the punch with GKE. It's now an EKS as well. Trainium 2, who likes a monopoly here? Nobody. Why? Because NVIDIA has it right now with GPU compute and inferencing and all this other, and we'll say it, and I know we're online for this one, crap. You thought I was going to say the other word. But now with their own chips through Trainium, basically built on years upon years of their Graviton research, they're bringing in these new chips that will revolutionize the way we do things. And it's been used today. Anyone see the Claude 2 announcement? No, so not Claude 2, Claude 3.5 V2 Sonnet. Guess what that's running on? Not NVIDIA. So that's the reason why it took a little while. Insider info, AWS don't at me. Other announcements, a bunch of Kubernetes stuff, but let's be honest, we're here for serverless. Databases, it's relevant, you'll see in just a moment. Aurora Postgres limitless, quite literally what it implies. If you have deep pockets and you have a lot of transactional SQL you need to run, you can use Aurora Postgres. God, their naming is so difficult. Amazon Aurora Postgres SQL limitless to actually allow it to scale for you and create custom app logic around that as well. DynamoDB, warm throughput. You can actually pre-warm your Dynamo now. The idea is you can say, hey, I've got a lot of NoSQL writes that I'm going to have to put in for session data, where else have you. You pay a little more just to have it ready. Why it's great? You can have warm indexes. And anyone who's had to make indexes before, if they sit cold and they haven't been accessed in a while, or if they're in tiered storage, it's not great, especially for you open search people. This is a great one. Price reduction. We're actually getting things cheaper. Dynamo got cheaper basically to run when you're running it natively through on demand as well as global tables. Long story short, at times we might have to have a global or regional, shall we say, architecture for us here. One day when the Brisbane region comes out at one point or another, I don't know, maybe in 2040, we'll then be able to go across both Melbourne, Sydney, and Brisbane at a much better rate. Scale to zero. So you can actually spend almost nothing when it comes to compute units for Aurora Serverless. That wasn't the case before. Aurora Serverless v2 sucked because it couldn't get to zero. Now you can. So it makes all our lives a little bit easier. And multi-region strong consistency. Dynamo, global tables weren't that great with consistency. Now you can have strong consistency. But as always, it's not in Australia. Probably will be sometime later this year. Caveat, if you see anything here today that is not in Australia just yet, you always have the rule of thumb of 6 months to a year. Aurora DSQL. This one's amazing. Distributed, multi-region, multi-writer SQL. No price as of yet, but it's active to 9939s when it comes to availability for multi-region. The caveat is you're going across 3 regions. 1 to witness and 2 for actually all interactivity. Buyer beware, but if you can utilize it and you're at a big enterprise, damn. By the way, if you're thinking Google Spanner as a competitor, or Spinnaker or whatever it's called, this has a 1 millisecond latency. Google has 4. So if you're running lower latency writes across regions, it's much better. And then a bunch of other stuff came out. Oh, 1, 2. All right, networking and content delivery. We're almost there. I can feel the pizza getting cold as I speak. CloudFront supports gRPC. Who would have thought that finally came out? Took them long enough. But it is great that it's out. For those that don't know, it's a new form of, well, not even new. It's another form of doing API endpoints besides REST, and it's basically like an always-on sort of thing, really. VPC origins, no more ALBs. Then it also includes VPCs. Sorry, also includes Lambdas. I can preface my Lambda with a CloudFront. I don't need an API gateway. I don't need anything like that. I can just use CloudFront for that. It's great. Just buyer beware that you're exposing something without having a middle layer, like a load balancer, which comes with its own headaches. Cloud Functions have an update as well. So not Lambda at Edge, but CloudFront Functions specifically, to be very specific at what they do now. You can update the origin viewer request only, but now they've just basically got a little bit more oomph. You can now write custom logic in your CloudFront Functions, and some other stuff that came out like Lattice, which unfortunately is not being used as much as it should be. Analytics. I'm going to power through these, like I said. So if you want to look at them later, they'll be up on the YouTube page. Better brokers for MSK, quicker, faster, a little bit pricier, but the benefit that I like is that accessibility is there. Next generation SageMaker. Anyone use SageMaker here? It's very pretty now, and it actually has a scale to zero option for some of its stuff. So hooray for finding some way to save money with AI. Didn't think I'd say that today. AWS Glue 5.0, it got better. It now supports Spark 3.52, Python 3.11, Java. If you use Java, we'll talk about that afterwards. We'll get you off it ASAP. And a bunch of other stuff came out for analytics. Take a picture if you want, or check it out afterwards. Machine learning and AI. We all saw this one coming, right? But hey, at least we saw some usable things. Prompt optimization for Bedrock. You can tell Bedrock how to respond, in what variants to respond using templating, made things better, and you can go model specific. The one that I'm most excited for is coming up later, not right now. Bedrock flows. You can imagine a similar sort of fashion in which that you do step functions in a sort of way, or the old workflow sort of functions they had before with Bedrock. It's really just an enhancement of what they had before in just prettier colors. Scale to zero for SageMaker, mentioned that earlier. Anything to scale to zero makes my life a lot easier and a lot happier. And other updates. One that I didn't mention was Bedrock prompt caching. Saves money. Basically, if there's been a request or a prompt that's gone through, tokens, which are basically just words that have been given a numeric value, they're basically cached, which means they're just cheaper to execute again. And model distillation, this is basically where you can do fine-tuning using a student-teacher model. A little bit beyond me, but hey, it does kind of make sense. You use one LLM to train another LLM. Famously, you all know about DeepSeek at this point, right? Yeah, there's a bunch of DeepSeek models that have been distilled using Qwen, using Llama, using everything under the sun. Automated reasoning in Bedrock guardrails, you can basically say, hey Bedrock, please make it more secure. Please don't, swear when you respond to someone and ask a silly question, et cetera, et cetera. Multi-agent collaboration is just a whole agentic AI process through Bedrock. Gonna say this right now before I continue. A lot of the stuff that you see here is in preview. So give it about a year and give it another year on top of that for them to get enough hardware in Australia. Going on. Nova, they made their own models that aren't bad. The first Titan releases were very average. The Nova models are not average. They're better than average, which has been a great surprise. In particular, the pricing. So if you are using it for your own LLM workloads today and you don't want to go through the Claude side or you don't want to pay for the other third-party options, Amazon's models are actually functional. Buyer beware. You want to look at obviously what the environment is like. If there's new LLMs, try to use them first. Prompt caching and routing. Mentioned that earlier, very excited about that, and then a bunch of other announcements. And finally, serverless. Took long enough to get there, but hey, that's what you're all here for. App sync events, kind of a similar sort of concept that we had with event sourcing through Lambda, except we're strongly tying that to WebSocket APIs. Event bridge latency reduction. Say it with me, event bridge latency reduction. That's huge. It just basically means if you're using event bridge today, it's better. Simply put, 94% improvement, which means that not quite yet, but we're getting close to a comparison of an event bus at latencies that are getting to that Kafka level. And one which isn't mentioned here, you can actually do multi-account event bridge sources. I can target a Lambda function in another account, so I don't have to go event bridge to event bridge, which is huge because that saves you a lot of money and also saves you in latency hops too. Snapstart. So I talked about this last time I was here, 2023 late. Long story short, it was only for Java before. Now they have it for .NET and Python. So if you're a .NET or Python developer, it will basically capture your code in its init stage, take it as a snapshot, and when you run it, it'll run it from init. So it skips quite a few things. And the best part is your cold start times from we've seen in Python went down from, mind you, caveat, 256 megabyte Lambda functions. It went down from about 650 ms to 240 cold start times, which is huge. For those that aren't aware why that's important, a lot of companies, they have quite a lot of SLAs tied to their application response times. For example, trading, for example, companies that have timeouts that are set for certain processes, a lower cold start is much better. Event source mapping, CloudWatch metrics. You can basically have your metrics be an event source for your Lambda functions and such. Step functions now basically have the ability to have comments inside your step functions. So JSON-ADA and variables are now present. It means that you can simplify the way you build your step functions instead of relying on third-party tooling or CDK for abstraction. You can follow the 4 letters that should be applied to everything in IT. KISS, keep it simple, stupid, by just having it all directly built in. Provision mode for event source mapping as well, which is an expansion of that, allows you to basically use things like Kafka for event polling resources. And then finally, all the other announcements. 3.1.3, so if you follow Python closely, the .13 release was huge. They changed a lot of the old libraries and made it much quicker. Node.js support, we're all forced to use it. It's very popular at the end of the day, but hey, 22 is getting better as well. And then a few other pre-invent releases. For those online, I hate to say this, unfortunately it's pizza time, so we're taking a break. But for the rest of you, turn around and dig in. And if you want to chat about anything you've seen, give me a shout. Thanks, everyone. We'll be back in 20?
Maybe 15, 20 minutes.
15, 20 minutes.
I think thanks for staying, not running away after energetic presentation by Bojan. I hope you enjoyed pizza. Well, now we have Michael today here, who's going to talk about some really cool implementation, as I said, of VR assisted referee, VAR assisted referees for powerlifting competitions. So, welcome, Michael.
Thank you. So a little background, I guess. I work for a company called ZeroW, and amongst other things, we run the Australian Powerlifting League, which is currently Australia's largest powerlifting league. And after helping them with the tech side of meets or competitions a couple of times, I noticed a common theme which inspired me to start this project. And that's basically what I wanted to share with you tonight. It's really intimidating to come after Bojan, who's such an energetic and engaging speaker, but hey, I'm going to do my best. We're going to talk about the problem, what I'm trying to do in terms of solving it. I'm going to desperately try to stay away from the ML side of things, even though for me personally, I think that's the most exciting part, and focus instead on the serverless part, which is actually very important. So, some context. Anyone who appreciates sport or watches sport regularly will have noticed that virtual assisted referees are incredibly common, whether it's football, tennis, you name it. Almost every sport has some form of virtual appeals mechanism. So that, say in tennis, if you dispute a line call, you can call the video referee and get a decision. In strength sports, whether it be powerlifting or Olympic weightlifting or anything like that, there is no such thing. It is purely down to human decision making. And worse, there is no appeal whatsoever in most federations. So that can become a really contentious issue, particularly as the sport grows and prize money becomes larger and it becomes more high profile. So an event I recently attended in October, the total prize pool was nearly 100,000. And the video I'm going to share with you, a particular lifter lost first place based on a contentious call, which not only cost her first place, it cost her $20,000. That was the inspiration. So the goal here was to leverage AWS serverless components to try and orchestrate a computer vision and natural language system that's going to provide impartial video analysis and real-time feedback if required. So I think a key point that I'm going to refer back to over and over again is that it's not intended to replace human referees. It's meant to provide a court of appeal, so to speak. So I'm going to play this video. Hopefully I have the sound turned off because it's awful noisy. So this young lady is attempting to squat 240 kilos. Now, for those of you who don't know, and you probably don't, the definition of a good squat is when the crease of the hips goes below the top of the knees. If it goes below, it's good. If it's above, it's not. So my question to you, having watched that, what do you think? Who would say good lift? Good? Yep. It was a split decision, 2 reds, 1 white. So she lost by 1, she missed the lift by 1 referee's decision. And she was understandably very upset. Her coach had recorded the thing on his mobile phone. They approached the panel. They approached the organisers and they did their best to protest it, but there is no such mechanism in place. And so really she had no way of changing things, and she came in second and lost the money and was understandably very upset. And I think for me, even worse from the sport's point of view, is it damages the credibility of the sport. If as an audience member you're watching this thing and you go, well, I don't understand why that wasn't a good lift. It's not a great look. If there is a contentious decision, there should not only be a method of appealing it, but there should also be an explanation for why it was good or not. So that was the goal to try and fix. So I think I've already covered this, but we'll go through it anyway. So these disagreements on all of the reasons for failing a lift come up regularly. The single most common dispute is squat depth. In powerlifting, we compete on 3 lifts: squat, bench press, deadlift. Squat depth is the most common, but it's far from the only one. There's about 30 vectors for failure altogether. Initially, I was trying to bite off more than I can chew and come up with something that would deal with every single possibility. But after seeking a little bit of advice, I decided it was better to break it down into bite-sized chunks and try and solve one problem first, which is squat depth. This has always been a problem in these sports. You can go back to the Olympics in the 70s and watch disputed gold medals that have come down to exactly the same situation. What's changing is that at an amateur level and at a non-Olympic level, the amount of money that's on the line is growing substantially. These competitions are no longer being held in gyms, they're being held in professional venues, they have professional organisations, and there's big money on the table for the winners. We talked about the issue of integrity and diminished trust amongst the audience. And from my point of view, it actually also presents an opportunity. So for me, when I watch, say, a tennis match, I'm going to keep coming back to that because I'm not such a cricket guy. When I see a disputed call about whether a ball is in or out, and they do call on the VAR, to me that kind of heightens the tension around the whole match. It brings an additional element to it that doesn't detract from the match, it adds to it. So I think that if we play this right, we can do the same thing. I believe that you would need to set it up so that they had a limited number of appeals. Otherwise you'd be bogged down on appealing every single call. I'd say, 1 appeal per meet, but that's neither here nor there. So my proposed solution, we mentioned already, it's a supplement, it's not a replacement for human refs. We want to provide an objective, measurable second opinion and an appeal mechanism. So my personal view is 1 appeal per meet. It encourages some kind of strategic use of your appeals. You're not going to appeal your first attempt, you're more likely to appeal your second or third attempt, and so on. It will be impartial between refined pose estimation and refined classification. We can provide a reliably quantitative and verifiable mechanism to confirm whether the lift is good or not. And we can actually also turn that into a feedback loop for training referees to make better decisions. There's actually some other opportunities that will come out as we get further into this. In terms of the way we present this to the audience, I think it's really important to provide 2 things. First is a visual overlay of the lifter's skeleton, so they can see the movement of their limbs through the lift, in particular the key points that are actuated during the lift, and a natural language explanation for the reason for failure. So with that in mind, the really basic architecture was that we would have a camera, we'd use AWS Kinesis to stream the video, we'd save the raw video to an S3 bucket, we then perform inference through using SageMaker, we'd save the annotated video to S3, and we would then pass the decision to Bedrock to provide the natural language interpretation of that, which in turn would be served via a Flask app. The Flask app, I believe, should be running all the time in the background. The commentators can constantly refer to the natural language output to let them provide more richer commentary. The number of times I've stood there and heard the commentator struggling to give good commentary because he also doesn't understand why the judges have made a call. Yeah, man.
Are they streaming?
Yes.
Or is it?
Yes, they're streaming.
Okay.
Yes. I think it would be valuable for commentators as well. We would only put it up on the main screen when the lifter chose to use their appeal. So this is a very simple overview. Obviously a step function try and orchestrate all of this. This is a simple view. We'll dive a little bit deeper. So why serverless? And then some of the big challenges. So serverless it's a no-brainer. These kind of competitions do not happen every day of the week. Mainly they will happen on weekends. If you have a service that's deployed full-time and doesn't scale to zero, you will spend a lot of money that you don't need to. So serverless is the only sensible economic option as far as I'm concerned. Don't have to worry about maintenance type stuff. We can handle demand spikes and different traffic, different number of events. What we're finding more and more is that as the sport grows, we have to run multiple platforms at a given meet, which means that at the same time we'll have 2 or 3 different lifters on 2 or 3 different platforms all competing at the same time. So we need to be able to scale that out. We also are finding that multiple events are happening on the same day in different places. So being able to scale in that way is also really important. There is a problem, and this is something that Bojan has talked about many, many times. At this time, as far as I'm aware, we don't have a GPU-enabled serverless offering from AWS. I say GPU, but I'm going to use the word accelerator from now on for reasons that will become clear. I think Google beat them to the punch. I expect that AWS will follow suit in due course. That's the only component of my pipeline for now that is not serverless. As soon as I can, I plan to change that. Bedrock already does this, and this is one of the frustrating things for me. Bedrock is a serverless service, and it's doing exactly the same thing. It's a little mind-blowing to me that we can't do the same thing for other non-LLM applications. Machine learning and deep learning is so much more than just large language models. So I'm looking forward to seeing that come out, and I know that I'm not the only person. So like I said, for now, I'm using SageMaker endpoints for accelerated tasks. I'm using ECS and scale to zero, which gives me serverless-like. It's technically not serverless, but it does the same thing. So diving in a little bit and talking about this, the first and most important part is the ingestion and pre-pro of the video files. You don't want to be just recording one long video of the entire meet. We only want to capture the important part of the lift. So we have a call audible from the head referee where he says lift, or whatever the specific command is for that lift. That triggers the stream to start. Kinesis does the streaming. Firehose then does the on-the-fly transformations. There's 2 main transformations. Number 1 is cropping. Number 2 is converting the file format. Every different brand of camera likes to save to a different video format. So your iPhone, for instance, saves to .mov. MOV is a pain in the ass. When I run inference on that, it rotates at 90 degrees. It's very annoying. So a really important step to get consistency is to convert it to MP4 and strip all the metadata so that you can consistently get your video oriented correctly. S3 then stores the raw video. DynamoDB is acting as a store of state. So it records all of the critical data for each lift attempt and all of the metadata associated with each step in this pipeline. If there's any questions, feel free to jump in any time.
So are you storing it like in snapshots, like every 1 minute is a new file?
No, I did consider that, but the actual lift time is very short. If you only capture from the lift command to the rack command, it's generally not much more than 20 seconds. So there's no need to perform chunking. I had considered it, but after some experimentation, there's no value in doing it for such a short clip. But it's a good question. It was definitely something I considered. So yeah, Dynamo is the store of state for everything. We run a separate piece of software that's our meet control software. It passes a JSON packet to the pipeline that contains the lifter ID, the type of lift they're executing, the lift number, and all the other key information associated with that attempt. And then it saves each of the bits of data, metadata associated with each stage in the pipeline. If we have any failures along the way, then we have the opportunity to execute appropriate failure handling.
How will you populate this metadata, like, for example, the lifter ID? How do you recognize that you are the lifter, your ID is 123 and he's 555?
So the Meet software calls the next lifter to the platform, and at the same time it passes the JSON to this app. So I read this wonderful book about microservices architectures, and I'm trying to learn from it. So we run the Meet software completely separately from things like this system, as well as the judging light systems and a couple of other bits of software that we've written. It records everything from the tenses at the transition frame, we'll come to that, the inference results, the explanation text, all the timestamps, all the critical data. So just an example of some of the kinds of things that we might store in our DynamoDB. To me, the partition key is a composite one. It's the lifter ID plus the lift ID. So again, no one will be familiar with powerlifting, it's a little fringe. Each lifter gets 3 attempts at each of the 3 lifts, total of 9 lifts. So you'll have squat 1, 2, 3, 4, bench press 1, 2, 3, 4, deadlift 1, 2, 3, 4. Hopefully that makes sense. And each lifter has a unique ID. The composite of those two makes each lift unique. The sort key, of course, is the timestamp plus the action performed at the time. And then the metadata is kind of self-explanatory, I think. This one was a really interesting one for me to learn. I've never used step functions before, so it was really cool to learn this bit. It acts as the orchestrator. It coordinates all of the many steps that are happening throughout this process. I didn't know about such things until I started to experience the problems of trying to coordinate these things. And a wise person suggested to me that this was the right thing to do, and it proved it to be very good advice. So I think of the step function as the conductor of our little orchestra. Inference. So SageMaker we mentioned. There are so many vision models out there that could potentially run pose estimation. I chose YOLO 11, mainly because it's pretty fast and it's relatively small. Speed is a key component of this for the customer. They expect the entire pipeline to be completed within less than 30 seconds, which is not a lot of time. Having a small model is important, and while transformers rule the roost in natural language applications, the same is not true in vision. CNNs and similar models are still really high performing, and you can get similarly good results with a much lower memory footprint. So I've chosen YOLO Pose for that reason. Let's touch on the accelerator part, because this one was really important for me. In his talk, Bojan mentioned Trainium. There's a second chipset that AWS recently released. I always use the short name because I can't remember the full name, Inf2. Inferentium? Something like that. It's good. It is really fast. And it's so cheap. It is literally, if you compare the performance of a H100 to Inf2, 75% less cost and at least 1.5 times faster. So it's a no-brainer as far as I'm concerned. The only barrier to entry is a little bit of complexity. It's not a simple install. You need to build from wheel. You can't just go pip install. You need to compile your model differently. It won't just take a standard .pt model file. So there is a little learning curve, but it's far from insurmountable, if you ask me. And the payoff is more than worth it. So I would find it very hard to justify using an NVIDIA GPU in future for a task like this. So the key outputs from this model are the key points. And in the case of the squat, we're mainly talking hip and knee and their relative positions in space over time. And that over time bit is something that's really important, which we'll talk about here in terms of the turnaround frame. So I've spoken about how the whole lift might take 20 seconds. If we're running 1080p at 30 frames per second, that's around about 800 frames. So which frame is the right frame? That's an important part of this question. So we need to run YOLO pose first. We need to record all of the key points throughout. We need to flatten the tensor down to 2 dimensions. And then we need to identify which is the transition point, the point at which they reach the bottom of the squat and transition to the ascent. Because these things are prone to flicker, I found that you need to specify that you need at least 3 frames to corroborate it before you can say, yes, this is definitively the transition point.
Sorry, Mark.
Yeah, man.
When you say flicker, do you mean the model and how it maps them out, or is it the actual video input you're getting?
Both.
Okay.
Both. There are issues with the model, and I'm going to show you that in a tick, but yeah, it's both. And personally, I think that in a perfect world, you shouldn't need to take 3 frames. 1 should be sufficient, but we work with what we got, right? So for now, 3 frames that are consistently showing you that this is the bottom of the movement seems to be sufficient to establish that this is the inflection point of the lift.
So you'll probably get to it. How many millimetres are we talking about? Have you done this in sort of physical measurements?
Yes,
Yeah, okay.
logged it all to the log texts, absolutely, yes. And you can adjust it because camera perspective is a really important part of this. If you get variations in your camera height or your camera perspective, it can throw things out big time. And that's something that I need to work on. So all of this development was done off a single perspective. That's unrealistic, but let me not get ahead of myself. Anyway, once we've identified the turnaround point, then it's a relatively easy thing to perform the depth analysis. It's simply, are the knees higher or lower than the hips? And if the hips are lower, good lift. If they're higher, bad lift. It's not always so simple. I picked the squat, as I mentioned earlier, for 2 reasons. Number 1 is it's the most common. Number 2 is also the most simple. There are many, many others that are, I think there's 30 ways you can fail a lift. And many of them are hard for me to come up with a solution. So I deliberately picked the easy one first. But eventually we'll cover them all. Bedrock is awesome. There was a point before LLMs became so commoditized, when I can remember playing around with GPT-3 and all of these early large language models and tuning them to perform particular tasks. No one does this anymore. No one does, because we have such wonderful language models out of the box. It's now just about designing good prompts, designing good pipelines. And it's a joy to work with. I can't say a whole lot more than that. So basically, once the annotated file is saved to the second S3 bucket, Lambda is invoked, passes the key points, the classification, and various other bits of data to the LLM for a short explanation. And a really simple example might be this squat was no lift because the hip was 2 centimeters above the knee depth at the bottom of the lift. I'm playing around with different prompts to come up with more interesting ways of saying these things, but sometimes I can overcomplicate things. Simple is good. You mentioned KISS. It's a good rule to live by.
Kind of a feature request. I think you should have like a drop down so people say like a cowboy or like a pirate or something. Gen Z, there you go.
Totally.
Good for the outcome.
So the final bit, again, is just the delivery of the outcome. So I'm using Flask. Fast API will do the job, whatever your preference is. So it's just serving the information for the judges and the audience. It pulls the annotated video from S3, and it fetches the decision and the explanation from DynamoDB. And I'm using CloudFront to cache because it's faster. So one of the things that I've learned is that the saving time is not where I thought it would be. I expected all of the saving time to be around model inference, and that's true to a degree. And to give you an example, if I ran it on CPU, it takes me around 1,000 milliseconds per frame. If I run it on Inf2, it takes me less than 10 milliseconds. So yeah, it's just not viable on CPU. Putting that aside, in order to get the entire process to work in under 30 seconds, you need to optimize everything from the kinesis step all the way through to the delivery step. Take out as much waste as you can. And that's been a real learning experience for me. I'm sure there's still tons more, yeah, man.
Were the step functions probably, I want to rephrase that, sorry. Were the step functions a blocker in regards to getting that time to delivery?
Initially, yeah. Initially. And it took me some time and iteration to get it down. I'm sure I'm nowhere near as fast as it could be, but I'm hoping that with further refinement and practice, I'll get it down even further. So this is a more complete picture of the whole pipeline. So basically, once the camera gets the audio trigger, call audible, it triggers a Lambda function to start the kinesis streaming. It immediately starts the transformations on the fly using Firehose. Transformations are done by the time the video is saved to the bucket. You don't need to wait until the entire video file is saved to S3 in order to start inference. You just need a few frames to start being saved, and then you can begin inference. You need to be careful so that your speed of save doesn't become your bottleneck for inference. But with that in mind, I guess this is another way that you can save some time. Start inference, you don't need to wait until the entire video file is saved to S3 bucket before you trigger your inference pipe Lambda, which sends the raw video to SageMaker. SageMaker then runs the initial pose detection, key points, data extraction, and so on. We pass that information to another Lambda, which does the turnaround frame function. Right now I have a second Lambda, which is doing the depth checker. I don't think I need the second Lambda. I think I'm going to change it so there's only one. But for now, that's the way it is. Once that process is done, we save the annotated video to the second S3 bucket, which passes it to Bedrock, and then Flask, and so on. This is just a more complete picture of the whole thing as it currently stands. As I touched on with the step function question, I'm quite certain that there's a ton of improvements that I can make to this. It's been through so many iterations already. I'm certain that with more work, it's just going to get better. Yeah.
You said that the Lambda is passing video to SageMaker.
Yes.
How exactly do you pass it?
It's more just a trigger. It's more just a trigger.
Yeah, so you basically just say that.
Start reading.
Bucket object.
Yeah. Correct. Correct. So the SageMaker code and model reads the item in the S3 bucket. The Lambda doesn't do anything more than just say start.
And the other question, how do you find the resolution? Does it impact the processing time?
That's a good question. YOLO 11 currently normalizes everything down to a pretty low resolution. I question whether that's a good thing, and it's one of the things that I want to explore. I'm currently recording all of my training files in 1080p. I think it's actually processing in 640, which is a very low resolution. From all the literature, it assures me that there is no gain from increasing resolution. I want to test that. I'll let you know. I'll let you know. What next? Sorry, I lost my train of thought. That's pretty much for this slide, unless there's any other questions.
I guess
Yes, sir.
maybe more of a general question, but why doesn't the lifter wear some sort of sensor?
Then you have the complexity of having to pass things back and forth to make sure that, yeah, it's just more complexity. So what I aim to do, and we'll see it in the next demo video I show you, Most vision models are trained on the COCO dataset. COCO is great and it has a lot of different objects built in. Lifter is not one of them. However, it's not so hard to fine-tune it so that it adds that extra object. Because really, lifter equals person plus barbell. So I think if you feed it 300 decent videos that are properly annotated and fine-tune it on that, you have your new lifter object. And it solves that problem. You don't need a sensor. It just automatically says, oh yeah, the guy holding the barbell is the lifter. But you'll see it very clearly, this problem. This has been a recurring problem in my demo video. It works, but it's not great. So perfect timing. This gentleman is 19 years old and he is attempting a squat of 380 kilos. He was attempting, his lift after this was a world record. What you're going to see is a problem that I encountered throughout, which is that the model wants to superimpose the skeleton on the person with the highest confidence interval. That makes sense. For inference, I could control that by setting the region of interest to the center area of the screen. And that works just fine. It ignores every other figure, inference performs correctly. But when it comes to superimposing the skeleton, as you'll see, it's kind of annoying. But it works well enough for now. Yeah, it jumps back and forth. It's really annoying. The confidence interval is just too close that it can't make a decision. You can see clearly enough, though, from the skeleton, it stays on him long enough that you can see that the hips do go below the knees. It's clearly a good lift. And the model comes back with an appropriate result. I was really tempted to try and do a live code demonstration, but I've been warned off it for now, and it's just one more vector for failure that I just didn't want to try out for today.
The lifters, they normally go that much further down?
Not necessarily.
Right. Okay.
Anything below parallel is acceptable. That is unusually deep.
Right.
Which, I mean, the guy is a human, he's a freak.
Down and then he's got to try and get back up again.
Exactly right. You want to go as little below parallel as you possibly can. Everything else is waste.
Yeah.
But the guy is a human freak. He's 19 or 20 years old. He holds a number of outright world records. He's still growing. To give you some idea of size, no, you can't see clearly. There's one of the spotters who's a little bit taller than me, and he looks like a midget compared to this guy. He's a freak of nature. But anyway, it's a sport full of freaks.
In a good way.
In a good way. In a good way. So yeah, just to try and summarize, I think we explained the serverless thing. Inf2 is my go-to choice for accelerators now. I long for the day when AWS offers us a true serverless solution. May it come soon. Step functions to orchestrate and coordinate everything. DynamoDB to track status and handle any failures in an elegant manner. There is a ton of work. In my mind, this is the biggest thing. The jury for me is still out as to whether it's a two-model job or a single model job. There's no doubt in my mind that we can fine-tune YOLO to clearly identify who the lifter is. We spoke about that a second ago. But I think there are, for some of the other mechanisms of failure, there's an argument to add a second model to the pipeline to perform separate functions. And we talked about trust and acceptance. So, in terms of the technical improvements, I mentioned earlier on that using a single camera is not okay. As an audience member, as a lifter, they're expecting that the judges are looking at this from 3 different angles and making a democratic decision based on those 3 different angles. Each referee casts a vote.
Are the referees physically located in different angles?
Yes, the head referee is at the front, then you have a left and right side ref. So my plan would be to have cameras located, ideally if I could get them to wear the camera, I would. Maybe I'll get them wearing those Meta Ray-Bans or something like that. I don't know. I don't have the money for that, but that would be ideal. But yeah, in order for it to be truly credible, I don't think it's necessary to get the right result, but for it to be credible in the eyes of the audience and the lifters, it needs to replicate what the human is doing as closely as possible. Fine-tuning models, I could talk till the cows come home about this one. The biggest issue around this is gathering enough good video, getting a balanced enough data set that captures enough of each of the mechanisms of failure that we can then annotate and train it to recognize each mechanism of failure. It's not as easy as it sounds. It's the most challenging part for me. Particularly some of the more nuanced rules around powerlifting. So one that I'm really struggling with is the audible instructions that the head ref gives to the lifter. So as an example, the head, at the end of the squat, he stood up, he's holding the barbell, head ref gives the instruction, rack. If he racks before the call, no lift. I'm not quite sure how to handle that yet. There is a solution, but I just haven't figured it out yet. This one actually doesn't belong on this slide. This is more of a business development extension thing. It's an obvious thing to me to expand into Olympic weightlifting at some point in time. The difference, for those of you who don't follow it, in Olympic lifting we do snatch and clean and jerk, as opposed to powerlifting where we do squat, bench and deadlift. It's the same thing. If it works for one, we can get it work for the other. And they have the same problem, so why not? One that has really surprised me is the exercise physiology and rehab side of things. This I didn't expect, but while working on this and showing people, we have a number of exercise physiologists who work within the organization, and they're doing rehab on people who've had maybe motor vehicle accidents or some other traumatic injury, who need to learn how to walk again or need to learn how to function physically again. And one of the problems they have is what these guys call proprioception, which means the ability to visualize and form a mental connection between what you think you're doing and what you're actually doing. It kind of sounds weird, but I don't know how else to explain it. And they believe, and it makes sense to me, that if you are able to give them a visual of to support the verbal feedback you're giving them, that is going to make it easier for your patients to improve and rehabilitate faster. My boss has a vision of licensing and offering it as a service and all of that sort of thing. Let's cross that bridge. We need a functioning product first.
Yeah.
That's pretty much it.
Awesome.
Thank you all. If you're interested, all the code's on GitHub. Feel free. If you'd like to reach out, please do. I would love to collaborate. If anyone enjoys computer vision, please reach out. Seem to be a rare breed these days, but that's okay. Thank you, everyone.
Thanks again.
Are there any other questions? We have Michael here. I think everyone is impressed.
That was awesome.
Thank you.
Real world serverless.
And I do have one question. How much time did it take to build?
To get to this point, I started in October. It's been an after-work thing. I have been staying up kind of late, so I haven't been tracking time, to be honest. When we first started it and I was talking about it with my workmates, they're like, nah, it's not possible. That's a strong motivator for me. My response tends to be, fuck you, watch me.
Well, I think it's very encouraging, right?
Yeah.
Yeah, absolutely.
Like a couple of years ago, that would be impossible.
Absolutely.
Another question. Cost, order of magnitude. You obviously talked a lot about scale to zero. Like, what is it costing to run when nothing's happening, and what is it costing when there's just like a normal meet? And I know that might be hard, but like, we're talking ballpark between tens of dollars, hundreds of dollars.
Right now, it's hundreds of dollars per day per meet. But I'm quite certain that I can get it way down. The big driver of the cost is the inference bit.
Yeah. Makes sense.
Yeah, but I mean, there are a few pointers to me that indicate that it's incredibly inefficient the way I'm doing it right now. I just need to get better at engineering that part. So I think we can get it down to tens of dollars per day. That's on me to become a better engineer.
Is there a stepping point where you provide video to the refs with the wireframe?
Yes.
So that they can then see that.
Yes.
And they're going, yeah, right.
Yes. Yes. That's what I'm doing with the second round of training data.
Okay.
As I gather the training data to run the fine tuning, I'm first pre-processing using the base model and saying, okay guys, tell me why this is a wrong decision. And let's go through and let's annotate it. And once we can annotate the raw video correctly, we'll teach it to come out with the answer it should be. Right. However, it requires that you sit down with a really experienced, really qualified referee. Right. And like many things in life, there are different levels of quality. So.
Have you considered any visual cues? With a lot of computer vision projects, they'll have like stickers that have guidance measures, especially with things like, this is for everybody as well, your length from your hip to your knee being different and such.
Yeah, I've considered it, yes, I've considered it. For squat, I don't think it's necessary, but for some of the other issues, I think it's going to become necessary, absolutely. I can't see any way around some of them. We'd be here all night if we talked through every detail, but I mean, as an example, when you deadlift, the bar can't come into contact with your belt on the way up. I'm not quite sure how to do that without markers. Yeah. So that's what would be one example where I think we should definitely be using markers, but not the only one. Yeah.
Sorry.
Not at all.
Your camera that you're using, is there any local processing that's done on the camera, or is it just a raw feed?
Just raw feed. Just raw feed. Have been talking about doing something smarter and doing processing at the camera level, which would make a ton of sense. It's going to take a lot of load off the pipeline, particularly all those transforms. That takes way more time than it should. I think that would be a really logical thing to do. The challenge, though, is getting consistency at different meets. We don't want to be in the position where every single meet director has to use our cameras. That would cause a lack of adoption. Yeah, have been thinking a lot about it though.
I'm just curious how this solution can be applied for some kind of weightlifting sports that need to hold up the weight instead of repeating the legs. Because I'm wondering how the data can be captured from that kind of sports.
I think the basic principle is the same. The difference is, let's take snatch in Olympic lifting as an example, where the barbell needs to move fluidly from floor to overhead, and you need to achieve lockout at overhead. You're looking for the barbell to be stable for multiple frames at the apex. You're also looking at lockout, which can be defined as the relationship between the wrist joint, the elbow joint, and the shoulder joint. So I think the fundamental process is the same, but I also think that we need to identify more key points than the base model currently does. So one example that's been on my mind a lot is feet. Yellow 11 doesn't pick up feet very well. And particularly in Olympic lifting, what's happening with the feet is really important.
So there are models that can do feet? Is that like a thing? Or
Maybe. I'll get back to you. I was looking at one called Poseformer, but when I tried it out, it was just so memory hungry that I said, you know what, I'm just going to put this to one side for now. There are methods like distillation and quantization and various other things where we can take those models and make them more memory efficient. I'll get around to it.
Okay, so this is, it's kind of a naive question, right? But because I don't understand the sport.
Sure.
So when the referee makes the call, whether it's a yes or a no,
Yes.
the
correct.
So what's the technical definition of where is the hip in human body? Like how does a referee as a human
I can pull up the exact definition if you want.
anatomically in the body? How do
Maybe just practical demonstration. Look at one.
So the referees tend to look at hip crease rather than hip joint. So hip crease means the visible crease that forms between your hips and your thigh as you go down. And once that hip crease falls below the top of your knee joint, that's defined as parallel.
Is that exactly picked by the pose estimator?
Yes. So we did there was a lot of doubt because the pose models look at joint center, not at hip crease. And so there was a lot of debate about whether it was fair, particularly for people with larger quads and bigger hips. The results are consistent. It's consistent with the human judging based on crease. So when a really good ref looks at a video and says, yeah, that's a good lift, the model says it's a good lift too. If for the sake of consistency, and this is one of the potential improvements, because I do think it may be a barrier to adoption, the crowd, the lifters, may want to see the key point being hip crease instead of joint center, then we just need to train in an extra key point. So YOLO currently comes with 17 predefined key points for the human body. It's not a problem to add a few extra with some fine tuning.
It doesn't vary on the gender.
No.
I believe there must be some standards around the clothes.
Yeah, so you have to wear the soft suits, same as in Olympic lifting. Yeah, lots and lots of gear standards.
I think we've got time for one more question.
Not so much a question, but more of just sharing a thought. Love what you're doing, and especially when we're going to have Olympics here, like you might be the key referee for all of this coming in. But then I'm sort of wondering, oh gosh, how big's that market? And the market around rehabilitation might be a much larger
I agree.
market for, but you're unpacking maybe some critical things that help physios and others rehabilitate people.
I agree, and I did not think of that at the start of this. This was just a passion project to prove that to myself that I could do it, to learn a whole bunch of new things, and maybe to solve a problem that I saw recurring. It was very unexpected to get the feedback from the physiologists, and I agree, I think that's a much bigger and longer term market. Definitely.
Cool.
Thank you all.